Okay, how do we approach this problem? Well, it's op amps, right? So, write out our op amp rules, right? So let's do that first. 0 amps, 0 amps, 0 amps, and 0 amp. Okay, so what else do we know? Well, we know that this voltage is equal to this voltage, but what's this voltage? Well, as you can see, there's 0 amps going this way, right? And since there's 0 amps across the resistor, there's no voltage drop across the resistor, which means this point is V2, and this point right here is also V2. Okay, what about this? Well, this point is V3, clearly, so this is also V3. Okay, pretty straightforward. Now, let's look at what it's asking. Find VA and V out. All right, how do we find VA? Well, we have VA right here, so let's do KCL here, right? No, we're not going to do KCL here. The reason is because we can do this branch, we can do this branch, we can do this branch, but this branch is the tricky one because there might be current coming out of here, there might be current going into there. We don't know what's going on here, so we don't want to mess with that branch. So what's something else that's connected to VA that we could do? Well, we don't want to do it here because then we're going to add V out as a variable, right? But we could do it here because this is connected to VA and it doesn't add any new variables. It adds V1, V2. We already know what those are and finds VA, right? So let's do that. Let's do KCL at V2. V2 minus V1, what's the resistance there? 4K. And then V2 minus VA, what's the resistance there? I think it was 12K. It's equal to 0. Okay, and now let's solve this. So let's split this up first. 1 over 4 V2 minus 1 over 4 V1 plus 1 over 12 V2 minus 1 over 12 VA is equal to 0. All right, again, we're solving for this one right here, so let's move this guy to the other side. V2 minus 1 over 4 V1 plus 1 over 12 V2 is equal to 1 over 12 VA. All right, now we have 12 in this denominator, so let's multiply everything by 12. What that gives us is 3V2 minus 3V1 plus V2 is equal to VA, and then simplifying this gets us 4V2 minus 3V1 is equal to VA. All right, pretty straightforward. Oh, sorry. Okay, so where do we go from here? The next step is we need to figure out what V out is. Okay, so where do we draw our KCL for V out? Well, again, we don't want to draw it at V out because we have no idea what this is, right? We could draw it at V3 though, so let's try doing that. Let's draw a KCL at V3, or write a KCL, sorry. V3 minus VA, first of all. What's that resistance? 13 kiloohms plus V3 minus V out over 65 kiloohms plus what? What's our final branch? So we have this one. This says 0, so we don't have to worry about this. We have this one. Now we have IA, right? And it's positive because IA is leaving. Okay, so now we just have to solve this. And look, we have V out. We also have a VA in here, but we can just use our answer from before and plug that in for VA, right? So let's look through this. All right, let's split up the fractions again. This time I'm gonna leave the kiloohms in the fractions. Last time I got rid of them because we were equal to 0, so we could just multiply all of this by 1K and get rid of all these kiloohms, right? But on this side we can't because well, we could, but here, I'll get there in a sec. I'll leave it in for now. You'll see why. All right, so what's the one we're looking for? We're looking for this one, right? So let's move this to the other side and rewrite everything. All right, now You see we have this in the denominator. So now we can multiply all of this by 65K. All right, so let's do that. And specifically kilo ohms is what we're multiplying by because, we need to get that in voltage. So let's do that. So that would be, I believe, 5 minus 5 VA plus V3 minus, plus 65K kilo ohms IA is equal to V out. All right, cool. We're almost there. Last step, we need to get rid of the VA because technically they don't give us VA. We only know these three in IA, right? So we know what this is by the problem. We don't know what this is. So we got to get rid of that. So let's plug in our solution from last time, right? We can just do that. Say minus 5, what was it? 4V2 minus 3V1, right? Plus V3 plus 65 kilo ohms IA is equal to V out. Now we can distribute this. We can distribute it. We can simplify it. I could write out all the steps, but I'm just going to fast forward a bit and get to our final answer. And also I'm going to rearrange it so that V1 is at the front. So it'll be this. And yeah, there is our final answer.